Travel from Earth to Mars is done, and now we just need to get to the surface. So far, things are looking good.
Greetings, greetings. Bill Nye here, CEO of the Planetary Society. Excited indeed for another landing on Mars. Everybody, this is just an amazing achievement. I know you hear people talking about it, but it is really a difficult thing to go to Mars. You can only go every 26 months. The Earth has to catch up with Mars. You got to go from 5 kilometers a second with 10,000 miles an hour, 15,000 kilometers an hour, down to 0 in 7 minutes. It ain't so easy. And so here to join us for the landing party, as we like to call it, are just some fantastic people, everybody. I want to thank the members of the Planetary Society, 50,000 of you, us around the world, who just think that the exploration of space is worthy use of our intellect and treasure. So I am honored to introduce a few people. First, I would call it camera right, but it might look different for you, is Raquel Nuno. She there she's waving. She's the Space Geologist on Instagram. You can follow her. And she, just to throw out some acronyms, she's getting her PhD at UCLA in planetary science. And Raquel, you worked a little bit on the ground, or testing the ground penetrating radar for this mission, right?
Yeah, we were, I helped look at the sites that we would actually test the ground penetrating radar that is on the rover right now going to Mars. And I'm so excited to have been a part of that.
It is just cool as heck. So next over is someone you know very well. By that, I mean, Raquel, you know pretty well, is Derek Muller, who, as you know, is the guy who does Veritasium on the electric internet, where you got 8 million followers. And you, Derek, you went and watched the testing of the crazy helicopter.
I did. I was so lucky to get there on like the last day when they were putting the cover on, so I could just like see inside it. And I didn't get to go in the clean room, but I was literally meters away from the helicopter. So that was awesome. I also went to the launch of the actual rocket 6 months ago. So it's just phenomenal to think that that payload that was in that rocket that I watched shoot up into the sky is just about to hit its target. It feels very surreal.
It's amazing. If you've never been to a launch, everybody, they're just amazing. The ground shakes, your clothing shakes, your hair shakes. The thing is so powerful because it's such a long way to Mars. And just imagine, you guys, we're sending a helicopter to another planet to get the view that, for those of you who've had flying dreams, to get such a thing for real. It's really just an amazing undertaking because the Martian atmosphere is crazy thin, 0.7% the atmospheric pressure of Earth. So the blades on this helicopter have to spin crazy fast, and then steering the whole thing is non-trivial. All right, cool. And Raquel and Derek, you'll be giving us some color commentary. But on top of that, people, the president of the Planetary Society, a member of the Perseverance Mars rover team, one of the people that helped pick the landing site for this mission, is Dr. Bethany Ehlmann. She's a professor at Caltech, along with being part of the science team. Bethany, this is a very, very exciting day for you. How long have you been working on this? 8 years?
Yeah, it's an incredible day, Bill. It's been about 8 years since first part of the teams that proposed instruments to this rover.
So everybody, we have a lot of problems here on Earth right now. First to admit, we got a pandemic. If you're in the US, we got this crazy apparent mismanagement of our electrical system. All right, we have people suffering in all sorts of ways. We have a lot of problems to solve. But this kind of mission still brings out the best in us. And it is working. It is part of this huge human endeavor to find out, to seek answers to two questions. that for me was best articulated by one of the founders of the Planetary Society, Bruce Murray, who was the head of this very same Jet Propulsion Lab during the disco era, as I like to say, when Voyager and Viking landed on Mars, Viking 1 and 2, and Voyager 1 and 2 left the solar system. Bruce Murray used to say, there's two questions that get to us all. Are we alone in the cosmos? And where did we come from? Put another way, what are humans doing here? So I'll just say again, if we are able to find evidence of life on Mars with this mission or the sequence of missions that Perseverance is part of, it will change the course of human history. It will be profound. Everyone will feel differently about being a living thing in the cosmos if we can find evidence of life. So the instruments that Dr. Ehlmann and her people, colleagues, worked on are put there to look, to seek something that might be a fossilized bacterium or fossilized Martian microbe, a Marscrobe, as I like to call it. And everybody, it would be a discovery as profound as Copernicus. The planets go around the sun, not the sun around the planets. Or Galileo, hey man, or colleagues, I looked at this dot in the sky and it turns out it seems to have moons orbiting it or something going around it. Oh, these are individuals who made these remarkable discoveries. But this discovery, if we are able to make, or all the discoveries we'll make, will not have been made by a person, will be made by a team, by a society who invested its intellect and treasure. And I'm in the US. This mission is from Jet Propulsion Lab in the US, but it's an international mission. There are scientists from all over the world working on this, and the instruments were built by people all over the world. It really is a remarkable day. Whew. Thanks for tuning in. Over to you, Bethany.
Well, you set me up. Yeah, it's really an incredible day, and for those of us on the science team, it's a mixture of just excitement, nervousness, anticipation. As I said, many of us have been working toward this for seven or 8 years. There's an enormous effort to select the landing site, enormous effort to build the instruments, calibrate them, build the rover, get it all integrated, get it to Cape Canaveral, and that was done during the pandemic. This was a heavy lift. This was Perseverance, and we are very much looking forward to getting Perseverance on the surface to start the exploration.
So it's got a piece of plutonium in it, and it will run for years if we can get it on the surface. And everybody, another thing I'm really excited about, as soon as it lands, you may have heard people talking on the NASA feed, which for me would be camera right. I don't know where yours is, but about the bent pipe. The bent pipe. So, Bethany, what is the bent pipe?
Yeah, so some of you who are following the NASA TV feed might have heard about bent pipe relay of the data to Earth of this landing event. Okay, so it requires some background. There are basically 3 ways data can get to Earth. First, the rover can send it directly to Earth from its antennas. But see, the problem is during the last 2 minutes of this landing, Earth has set in the sky. It's no longer up, so the rover can't communicate directly to Earth any longer. So then you have a few choices. You could do what is typically done with rover data, which is called store and forward. And that means the rover sends the data, and after some time, the orbiter sends it back to Earth. But that wouldn't be very exciting. We would all be sitting here waiting in anticipation for hours as to what's going on. So that is why NASA is doing what's called bent pipe communication, which basically means it's almost real-time relay, in the sense that as soon as the data goes from the rover, making its way down through the Martian atmosphere, it's sending its signals to the Mars Reconnaissance Orbiter, and the Mars Reconnaissance Orbiter is just acting like a pipe that kind of bends that signal and sends it back to the Deep Space Network dishes on Earth. So that is the bent pipe that everyone's so excited about, and that's actually really important for getting the last 2 minutes of this landing event.
So we're all hopeful that as soon as it touches down, the cameras will record something. So check this out, you guys. When the thing, it's just like science fiction, except it's real. So when the thing comes down, it's, except it's on Mars, it'll sound different. And it'll kick up dust, just like, I don't know if you've ever been around a helicopter when it lands. It kicks up dust. All right. So the cameras have covers on them, just a lens cap. But the lens caps are clear. The camera can see right through its lens cap. So we're hoping it'll take we'll get a couple pictures right away, and then poink, or the lens caps will come off, and we'll get an even sharper, better picture. So Raquel, what do we do with ground penetrating radar now that it's there?
Yeah, no, this is really exciting. So the ground penetrating radar is going to help us understand the geological context of Jezero crater. So we're going to be able to hopefully understand the different layers that are underneath it, so that we can pick really great sites to do some sample return. So doing some sampling of the rocks. And if we know the different layers underneath, that's really important. So essentially, the ground penetrating radar sends out a signal out, and then we listen to the echoes. So depending on the different layers, the echoes come back at different times. So it gives us a picture of what the rover is driving on, of underneath the ground of where the rover is on.
So you guys, one of my favorite hilarious jokes that I find funny and other people look at me cross-eyed is, I start by saying, some of my best friends are geologists. When you talk to geologists, they're extraordinary. They think, Bethany, you can talk about this. If you have the right rock, you know who was president or something. Like, every rock tells a story, but the geologists get pretty carried away. You can tell who's going to be president. No, I exaggerate, but this whole thing that people have talked about since I joined the Planetary Society in 1980, when Carl Sagan and Bruce Murray and Lou Friedman started it, people wanted to bring rocks back from Mars because every rock tells a story. And so just think, everybody, if we could bring rocks back from Mars that have evidence of fossilized Martian Marscrobes, be extraordinary. So, Bethany, how are they going to do that?
Well, I'll go, and then Derek, I think was gonna jump in with a thought here. But I'll just, one of my Caltech colleagues sort of famously said, in terms of talking about sample return from planetary bodies, give me a single rock and I will tell you the history of that planet. Yeah. We may need more than just one rock, but the bottom line that's so exciting about this mission is it's really the culmination of something that planetary scientists have wanted to do for 50 years, which as soon as we realize the rich geologic record that Mars holds, including of the very earliest part of the evolution of planets at the beginnings of the solar system. I mean, this record is gone on Earth, but it is there at the surface of Mars to grab and bring back a sample. So it's incredibly exciting. I don't know. Are you excited, Derek?
I am excited. The thing that I was actually thinking about was how Bill was talking about the sound of this craft moving through the Martian atmosphere and what that would sound like. And what that made me think of was that this mission has a microphone on board, which is something that the Planetary Society has been, lobbying for a long time. Is this going to be the first microphone that is actually active on the surface?
I believe the answer to that is yes. Someone can call in, fact check.
Yeah. But there's one on the surface, as we like to hilariously joke. And I was at a Planet Fest, Planetary Society event in 1999 with everybody's buddy, Buzz Aldrin. And the thing crashed. The Mars Climate Orbiter is on the south pole of Mars. Mars Polar Lander, I misspoke, is on the south pole of Mars, and so is the microphone, we presume, but it's in a rubble pile. But this time, we're pretty sure we're going to get a couple microphones there. And you guys, just to go on and on, I've been in meetings where people, I'm not going to say who, people said, well, you don't need to send a microphone to Mars. We know the composition of Martian atmosphere. We know the atmospheric pressure of Mars. We know exactly what it's going to sound like. You don't need to send a microphone. But as the mythic test pilot, Tex Johnston, is supposed to have said, he did a barrel roll with a 707. On an airliner, he did a roll, did 2 of them. He said, one test is worth 1,000 expert opinions. And that is a worthy sentiment, my friends. We don't know exactly what it will sound like, and I am very excited. Now, how often, Bethany, do dust devils go by on Mars?
Dust devils are actually pretty darn frequent. So one of the things, I'm privileged to also work on the Curiosity mission, and almost every day we take a dust devil movie, which basically means that we run one of the cameras so that it takes an image every few seconds, or most of them are tens of seconds, just snap, 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 images of the horizon. And, I don't know the exact statistics, but we catch an awful lot of dust devils, like hundreds per year. So they're a pretty common event, actually, a fun Martian weather phenomenon.
I want to hear what they sound like. That's what I want. What does a Martian dust devil sound like? Yeah. Have you all, has anybody been through a tornado?
I have not, but my understanding would be that these dust devils would be much less violent. Like if you watch the movie The Martian, you wouldn't get that sort of force because of just how thin the atmosphere is. Is that
there's
right,
so few molecules per cubic, whatever the heck, meter. Yeah.
Yeah, that's one. It's one of the liberties of the Martian is, he probably wouldn't have been impaled by this. It's hard to get a lot of force from wind when your atmosphere is very, very thin. But hey, had to strand them somehow. And I really look forward to seeing what Mars here's what Mars sounds like. We kind of got a hint of this from the InSight lander. I don't know if any of you Google InSight wind sound. One of the sensors picked up vibrations of the wind, so we have a bit of a sense of what it might sound like. But these will be the first true microphones on 2020.
It's just cool, you guys. So when I worked briefly on Spirit and Opportunity. Gee whiz, more than 15 years ago. The saying was, you want the cameras as high as a 10-year-old's eye. You want to have the experience of somebody being there, somebody being on the surface and feeling it, because you will just know. This is what we talk about humans all the time. You're going to notice something that it's hard to write software to notice. By having these sorts of observations, we're going to have insights, I guess that's a pun, about what goes on the surface of Mars. I mean, just think how hard it is, really, to get an image of, let's say, a water spout, a small, relatively small, spinning storm system at sea. It's difficult. We get images of them because there's so many cell phone cameras now, but just think if you landed on Earth one place in an area the size of a living room or what have you, how likely would it be that you'd see a dust devil or a water spout or a tornado? It'd be pretty hard, pretty unlikely, but these things happen so frequently on Mars. We have, I guess, would you say, thousands of pictures of them?
Yeah, that's right.
It's amazing. So, Derek, when you were talking with the people about the amazing helicopter,
yes,
what's the idea there? How is it going to work?
Well, it's a technology demonstration, right? So they're not going to try anything too ambitious in terms of science. They told me, the key is just to prove that you can fly on another planet, because that's a pretty daunting challenge in itself. And that the first flight is probably going to be a little hop up where it just, lifts up off the ground and there's a mutual selfie. So the helicopter takes a picture of the rover and the rover takes a picture of the helicopter, and then they're just going to sit back down. So I think if all is running well.
Come on. How cool is that?
I mean, if they pull that off, it's just, to me, it's phenomenal, right? Because you can't drive this thing with the time delay, so it's got to fly itself. It's got to charge up these batteries, which are kind of equivalent to like 3 cell phones worth of battery. The thing weighs, at least on Earth, about as much as a laptop. So super light with these couple big rotors, and it's just going to try to get up in the air. And if things start going well, I think they're going to get more adventurous, and they can fly for up to 90 seconds. So, on Earth, that might not seem like a lot for a drone flight, but I feel like for flying a craft on a planet that far away on a different world autonomously, that sounds like forever. And if they're able to do a few of these hops, like, it's just going to be really opening up a new dimension to space exploration, because we've always been sort of limited to either orbiting or crawling along the ground. Now you've got this great ability maybe to go really fast and at a nice height above the surface to get lots of information very rapidly. So, I think it's just incredible. Super exciting.
Well, so, the geologists always say they want mobility. Like Raquel, when you find a layer with the radar, you want to go where it is. You want to be able to get to it. So this is a big thing Matt Dallenbach and those guys talk about all the time, is being able to see a rock and go to it. Well, with a helicopter, it just seems to me you can get to a lot cooler rock a lot faster. I mean, it's cool.
Yeah, in geology, context is everything. You want to see, the extent of a geologic unit to try to understand, how it formed, how it has evolved over time, so that it would be hard, because the rover does drive pretty slowly. So if you have, maybe in future missions, if you have a bunch of, like, a swarm of these drones to fly around, you can get a much better picture of what your environment is. And I think that what's really great about this tech demo is that in the future, maybe we can have much more of these drones flying around, these helicopters flying around, both to get imagery, but maybe potentially they could help move things around in the future once humans get there. So yeah, I'm really excited to see what this helicopter does.
Let's go.
The things we're at JPL with the helicopters actually is, okay, we're like going to get the data back from the Ingenuity helicopter from Mars, process that, figure out what worked well, what didn't. But what we're already trying to figure out how to put larger payloads, like, what is a payload? That's the instruments, the stuff that scientists use to make measurements. So Ingenuity has a very small camera. But imagine that if we can hop from spot to spot and not just get images, but get, like, chemistry, like the things that we're using to look for life on Mars and look at minerals that record climate. So imagine if we could just fly around for miles and miles on Mars, hopping from spot to spot, recharging, maybe making chemical measurements at night, sitting in the morning to let our solar panels recharge, and moving to a new vista every day. That would be amazing. So this Ingenuity helicopter is sort of the first step of what we hope is that future.
It's just so ambitious, you guys. And, at the Planetary Society, I like to say we do at least 3 things. We educate, we have things like this. And these are shorthand expressions. We have a fabulous website. We host things like this in Planet Fest last weekend and this landing party today. We innovate, we have a LightSail 2 spacecraft. There's an image of the Nile River taken by LightSail 2. And in orbit right now, or on orbit right now. And that was built by contributions from the 50,000 of you around the world who just thought it was cool. And the estimates are we did it for about a 20th of what it would cost a regular space agency or administration to do. And the third thing we do is advocate. We go to European Space Agency, Canadian Space Agency, Japanese Aerospace Exploration Agency, Australian Space Agency, and the US NASA to advocate for space missions, for planetary science missions. Because you guys, people perceive the NASA budget, people think it's 10% of the federal budget. No, it's less than 0.5% of the federal budget. And the planetary science component or line item is 9% of that. It's 9% of 0.4%. It's a very, very small fraction of our tax dollars that go to these missions. And everywhere you are in the US and many, many places you are in the world, NASA affects your local economy. Money is being spent in your local economy in almost every county in the US. As the saying goes, money spent in space is actually money spent on Earth. And if we could make these discoveries that I've alluded to and Bethany and everybody have talked about, it would just be something else, you guys. It would just be profound. Evidence of life on another world. Hey, you like to think about things? Here's a couple things. First of all, Mars is smaller than the Earth, cooled off 1 billion years before the Earth did, had an ocean 1 billion years before the Earth did. Did life start on Mars? Mars is littered, covered, nailed with almost countless asteroid impacts. Did Mars get hit with an impactor? Stuff went through space, woo, 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 or as I like to say, and landed on Earth, and you and I are descendants of Martians. That is extraordinary, but it's not crazy. It's not absolutely nuts. It's something worth investigating. Then the other thing is just think how much we have learned about climate change by studying Venus and Mars. You know, in the 1980s, Jim Hansen and these guys realized that the Venusian atmosphere makes Venus crazy hot. And the Martian atmosphere keeps just warm enough to have ice and slush on Martian summer days. It's really an amazing thing. With a small investment, we seek answers to these amazing problems. All right. Whew. How are we doing out there? There's and they're the peanuts.
They brought up the lucky peanuts.
Yeah.
Ranger number 7, on the 7th attempt, decided to bring peanuts to the ops area just before the launch, and guess what? That mission worked. Now, we're not supposed to be too superstitious. We're engineers and scientists after all, but we love tradition. And ever since then, before launch and before critical events like entry, descent, landing, we have brought out peanuts and shared them with the team. And it's been really a wonderful little experience. And so this is something we're doing right now. And it's something that we just can't help ourselves. It's just part of the experience.
Well, speaking of the experience, how did the Perseverance team keep the tradition alive this year?
Well, this year we passed out little packets of peanuts to the team, and they can sneak one peanut in their mouth as part of to keep the tradition alive. But you know, this is part of the COVID experience, but we can't leave this one undone. So this is what we're doing, and this is going to help us land safely.
All right, thanks, Rob. I have some questions for you a little later on, but we're heading back to Swati Mohan, who is part of the landing team. She'll be calling out key milestone and events as they happen from Mission Control. So let's listen in right now.
So right now we're still about 20 minutes from entry, and the EDL phase is giving a last-minute confirmation of what will be happening in the upcoming changes to the vehicle, just to remind the team.
This will allow us to steer our trajectory as we make our way through the atmosphere. This is one of the things that allowed MSL, the Curiosity rover, to land where it did. And we're depending on the same type of entry guidance this time around to help get us very close to our target. As we make our way through entry, finish our guided entry profile, we'll do a maneuver called heading alignment, where we point toward the target and get ready to deploy the parachute. But before we deploy the parachute, we need to get rid of a set of balanced masses that have been giving us a center of gravity, or CG offset, throughout the guided entry phase. So these are called the entry balance masses. We also call this maneuver SUFR, S-U-F-R, or straighten up and fly right. So we'll go ahead and eject those masses when we get a trigger from the GNC system telling us that we're at the appropriate range to the target to do so. As soon as we deploy those,
how cool is this, you guys? Have these masses, we're going to let them go, and that'll straighten the space. It's just, wow. It's physics, people. That's physics. So, Derek, Raquel, you guys have a Tesla, right?
We do, yeah. How is this related?
Is it self-driving?
To a degree. I was driving in it last night very late, and I was relying on it pretty heavily to keep me going straight, flying right.
Because would you let go of the wheel for 7 minutes? Really?
Not 7 minutes, and you couldn't, because the thing would shut off. It tells you have to touch the wheel.
Yeah. But these guys, sure, we're going to Mars. It'll be fine. Yeah, just let go.
Let go and let the thousands of lines of code that have been triple, quadruple, quintuple checked against all possible scenarios. Let that take the wheel.
Yeah, and I remember very well the cold, what might affect the software that was tested and tested. Oh, here's Rob Manning. This guy, I've spent time with him. He is something else. Rob.
There's another radio that will continue transmitting a tone, so that like a flashlight that will allow us to at least see that the vehicle is still on, and that color of that flashlight tells us a little bit what state the rover's in. But soon after that, it won't be very long before we'll be able to hear more ones and zeros coming from the spacecraft. So this is a really exciting time, and it's just important to remind people this is there's a lot that can go wrong in a day like today. There are thousands of things that have to go right.
Yeah, we had success in the past landing on Mars. You'd think it gets easier, but it really doesn't. Why is it still so difficult?
Well, it's because it's involved thousands and thousands of things, hundreds of thousands of lines of code. There's 79 pyrotechnic devices. Each have to work perfectly. One critical wire short, or one key thing mechanism that doesn't work or breaks, and it's mission over. And so it's and it's very easy. We're human beings. We're not perfect. Mistakes can be made. We count on each other to find our own mistakes, and we work very hard to learn from the mistakes of the past. We've had many failures. Remind people, roughly half, around half of the missions to Mars over history have failed. And so it's that could happen today too. Even though we've had a nice, wonderful string of successes in the United States, it's still still a bit of a gamble that we have hoped that we have erred in the side of luck, and we've stacked the deck and loaded the dice to make this thing succeed. But if we do fail, and if something bad happens today, I can tell you, we're going to learn it. We'll have the data that tell us what happened. We'll know why. We'll figure it out. And if we are allowed, we will pick ourselves up and get us back on the horse. And if Congress and NASA allow, we will try again. As we always do, we will learn from our mistakes.
And what are the possible scenarios we could be looking at today?
Well, there's things like one of the key stressful elements for all of us is parachute inflation. But just even separating from the cruise stage is a pretty major event. Lots of devices have to work properly. Certainly, the heat shield separation, getting the descent engine started. There's no less than 16 rocket motors that have to work. 8 to control during entry, another 8 to control it during landing. I said it's a lot of stuff, and it all has to work. And guess what? We haven't done this before with this vehicle ever. This is its first attempt to actually land. We can't try this on Earth. We can't do. We don't have test pilots to try it out on this planet before the big show. So this vehicle is doing it for the first time. We've done the best testing we could do in bits and pieces, but it's as best as we could do. But I think our team is up to it. This team is the best. It's a diverse, intelligent, amazing group of people. People from all over the world who worked on this, not just here in California, but all over NASA, contributors from aerospace, universities, countries around the world. It is just an incredible, remarkable engineering achievement, and I am just so proud of this team.
Thanks, Rob. Now, let's listen back into mission control.
Flight, we're about 14 minutes from entry interface. The vehicle is currently preparing the heat rejection system that has kept the thermal system cool inside the air shell for about the last 6 months. This will allow the spacecraft to more easily cut the lines in upcoming cruise stage separation, which is under 4 minutes now.
Wow, 4 minutes, people. Woo.
Yeah, and that's when this
I was like that there on the side of luck too.
attached and sealing the whole way comes off.
You guys,
It's just the capsule.
if you're out there watching, would you please be nervous? Understand what's going on. They're on another world, and you know, you can get into the science fiction thing. Well, it's already happened on Mars. Well, because of the speed of light. Does it not happen here until that information gets here? Like, whoa, dude. The whole thing is just, it just gives you such, to me, it's just inspirational that humans, that we could figure out how to do this is really amazing. It's worthy of respect.
I know it's just a robot. It kind of feels like it's me going to space. You know, it's all of humanity. It's all of
yes,
there.
Yes. Testify. So we're less than 2 minutes?
I think we're about 2 minutes away from the cruise stage separation, yeah. So what'll happen is the cruise stage separates, and then there's about 10 minutes before the descent stage enters the atmosphere. So, but the cruise stage separation is a big deal because these have been wedded together ever since they launched here on Earth, and we've got to have a successful separation to continue forward with the landing sequence.
It's all built into the software. We've tested it over and over and over again. This team has spent 24 hours a day, 7 days a week testing this thing for years. And so this is really the culmination of all that work. So this vehicle is getting ready to push that cruise stage away. Once it gets pushed away, the entry system with the rover inside, with the rover still in charge, is going to get ready to take the vehicle, turn it to the right orientation, and aim it to Mars, and prepare for entering the atmosphere. This won't be long. Be prepared for this event.
We're about 1.5 minutes from cruise stage separation, about 11 minutes, 20 seconds from entry interface.
Okay, so it's about 10 minutes from cruise stage separation till entering the top of the atmosphere. From then on and out, things happen
We are
fast.
switching to MFSK tones. Telemetry will have stopped.
Telecom is confirming that the spacecraft has switched to broadcasting tones. These tones are received directly from Perseverance, but have very limited information content. We won't receive real-time information until about 9-10 minutes from now, once the Mars Reconnaissance Orbiter starts relaying information from Perseverance. We are under a minute from cruise stage separation, about 10.5 minutes from entry interface.
It's getting exciting. I have to admit, I am quite anxious, but very hopeful that this machine is going to do what we asked it to do.
We are seeing the heartbeat tones.
Okay, that means that there's no more ones and zeros coming. It's just the vehicle telling us it's still alive.
So, depends who you are. It's, you know, Rob Manning's worked on this 20-some years, 30 years. And here's this moment.
For cruise stage separation.
That's
We
what
have
we believe
indication
just
that cruise
happened.
stage separation has been confirmed by the spacecraft.
We're off on a good start.
Congrats,
In
Bethany.
about 1 minute, Perseverance's landing software will wake up and begin the final preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface. We're about 9 minutes from entry interface.
Okay, so cruise stage away, warming up those engines that are going to have to turn on after having been off for what 7-8 months since launch. So warming them back up again to get them ready to go.
After
We've got
when you're in deep space, it's 3 Kelvin. It's almost absolute zero in deep space for 7 months. 7 months, I mean. Wow. And everybody, if you're watching this, we have closed caption in Spanish, Hindi, Arabic, Mandarin, we are gauging people around the world. It's very cool. This is a human endeavor, bringing out, I say all the time, bringing out the best in all of us.
The data stream indicating the cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the 2 balance masks that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We're about 7.5 minutes from entry interface.
So, Bethany, right now we're going about 5 kilometers a second. We're going 10,000 miles an hour, something like that.
Yeah, you're doing a 5K. It's doing a 5K every second.
Every second.
Revolutions per minute.
And so it has that shape. Space capsules have that shape for the air, the aerodynamics, even on Mars, or maybe most especially on Mars, the aerodynamics.
Orientation and attitude via rockets on the back of that back shell.
Points carrier lock. Sorry, the DTE from Radio Science from Green Bank reports carrier lock. Do you see the carrier on the downlink?
All right, that means the Green Bank telescope is listening, successfully locked on to the spacecraft.
We are continuing to wait for entry interface. We're about 6 minutes and 45 seconds from entry interface. We have confirmation from Greenback that they are receiving direct-to-Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report. This is as
Nothing significant to report. We're just going into Mars at 10,000 miles an hour, but you know, it's routine. Nothing significant.
While we're in a quiet period, just a little preview. Once it hits the 6-minute countdown, that's when atmospheric entry happens. And then a whole bunch of steps happen real quick for about 7 minutes in terms of capsule going into guided entry, parachute up, heat shield off, rockets firing, parachute cut, descent, sky crane. It all happens super quick as soon as it hits the top of the atmosphere in this 6 minutes. And we'll just listen to them, I think, during that last bit.
We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, what we're looking for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle, and be able to listen to ones and zeros coming from a separate radio that's really designed to talk between spacecraft.
MRO reports the electro radio is powered on, ready to receive signals from the lander.
Okay. MRO is ready and able and waiting to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight Local 1
from entry interface.
Can you hear the way she breathes through her mask? Like she's put, whatever, at least 10 years into this thing. Here we go.
Health and well-being today to keep our nerves under control. But
around this time, a second spacecraft, MAVEN, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
okay. Very soon we'll be getting ones and zeros, I hope, from our radio on the rover. The entry interface is nothing more than just an arbitrary place in the sky that we've defined to be above the atmosphere. But from that point on, there's definitely atmosphere, and above it there isn't.
We are 2 minutes from entry interface. Perseverance is to transmit heartbeat tones, indicating everything is nominal.
It's like the Kármán limit in the Earth's atmosphere. Like it is, we'll just pick a spot. Okay, this is it. This is the atmosphere.
Doing well.
Yeah, and on Mars it's about 100 kilometers above the surface. So that's, kind of 12 Mount Everests stacked on top of each other is where we define that atmospheric entry point.
That's where you start experiencing drag, right? You start having to steer with the air, Martian air.
Yeah, that's one of the things that makes it so difficult to land on Mars. So Mars's atmosphere is thin enough to cause problems in terms of friction and heating, but it's too thin to be useful in terms of slowing the vehicle down appreciably. So that's what makes Mars so hard. It's a lot easier actually to land on the moon or an airless body than this super thin atmosphere. It's easier to land on Earth too with our thick atmosphere because you can use it to slow yourself down, but Mars is hard because it's this in between.
Yeah, landing on the moon's easy. Am I right, people? Yeah. It's nothing.
Easier.
Okay, that to me is it. That it should be right now.
Minute from
Maybe
entry
2
interface.
seconds from now. Oh, there we go.
Yeah, after atmospheric entry, I think the next main event is a little bit after 12:49, 12:50, where we'll hit something called peak deceleration.
We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your
It's like max Q on Earth, right? Maximum dynamic pressure when a rocket's sick. You got it. That's what you got to design for. God, I hope you guys thought of that.
From entry interface.
Bethany, I hope you
5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars.
Can you imagine?
Feel an atmosphere.
When you look at the Earth from space, that's about what you're seeing, Wow.
We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The
Right about now, it's
is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes. Yes. Yes.
10 Gs will make your eyes water, people.
10 Gs will make you faint.
Yeah.
From Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
That means it's basically changing the angle at which it's going through. It's kind of tilting up a little to catch more atmosphere and adjusting accordingly. In about a minute, the parachute's going to come out, which is going to be...
Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target.
Humans at their best, people. This is cool.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
5 soccer fields a second.
MRO is reporting good telemetry lock.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes. Yes. Yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
That's right where it's supposed to be.
Yes.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
So just 1 soccer field a second now. Football field.
Now the radar's ranging, looking for the ground.
It's down there.
Yes. Yes. Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation, and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
God, listen to her breathing.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have timing of the landing engine.
Description of they got a plan.
Taking
it has a way
photos,
to
it's
go.
doing photo matching, trying to find where it is and pick the safest spot.
About 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
Gosh. You could, if you were there, you could make out a baseball on the surface.
Accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct-to-Earth tones.
That's expected.
As expected.
Sky crane maneuver has started. About 20 meters off the surface.
20 meters. It's right there. Oh, God, it's right.
We're getting signals from MRO.
Signal from reconnaissance orbiter. The big pipe.
Touchdown confirmed. Perseverance safely on the surface of Mars. Ready to begin seeking the sands of past life. At this point, the descent stage has flown away to safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Wow, you guys, that was something else. I mean, we act like, of course, it was going to happen, but they really pulled it off. So let's see if we get these images. That's what's crazy making, man. It's just
Should be a couple few minutes.
When I go through that, the thing that I just keep thinking about is like the sophisticated orchestration of how that is possible, how that like requires the greatest of our intellect to, make that happen, not to mention a ton of money and a ton of time. I just feel like it's levels above most of the human achievements we normally see, which are always impressive. But this for me is like, the pinnacle.
It really is. It's so difficult. And, it's not just technically, it's not only technically difficult, but it's an organization. It's a management. It's how are we going to approach the problem? How are we going to coordinate all these world's foremost authorities to work together to achieve these things? And I know, Bethany, you were involved in these meetings, like, where are we going to land? Like that right there is just not a trivial choice, right? Where are we, by the way? Let's see. Here's a globe of Mars.
Go to the west side of the Isidis Basin, and just a little above the equator.
I found it the other day. You directed me there the other day. Okay, here's Planitia, Chrysa Planitia.
What about Utopia Planitia? Do you want me to grab my big globe, Bill? It's behind my shoulder.
Well, if you've got time, yeah, while everybody's freaking out that are very happy.
Perseverance is alive on the surface of Mars.
Here we go.
Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the
really?
image.
I'm stretching it for all of you.
Flight, this is OL3. I have the target point on the map when you are ready.
We are ready, OL3. Go for it.
Wow.
Where are we? Where are we?
All right. We'll take it. We'll take it. Let's see.
flight, I'll be moving in, showing you the safe zone that we've landed in.
Here's a picture.
The team has just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Later in the day. Like right now. It's just,
you want it all right now.
But this is something that always wigs me out about these images from Mars, is it's a place. You know, if you were somehow dressed properly, the right spacesuit, Sandy the squirrel helmet, you could walk around, you know, have a picnic carefully. But it's a place with rocks and sand and history and geologic information locked in the rocks, and it's really amazing, you all. It's amazing. I am honored to be a human today. It's not bad.
Yeah, it's a great view. Can't wait to get exploring. They were just trying to show, I don't know, we didn't get a good video feed. They're trying to show where we are, and it looks like the question is, did we land on the delta, or are we just to the side and we're going to be able to like turn around and stare at it? That's what I'm trying to figure out right now, is where exactly did we land? We clearly landed safely, but where are we? Hopefully they'll have a chance to get that up on the view for everyone.
We just got our second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. So you can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. You know, this is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together to do these kinds of things and make success happen.
He said it. He said it. Bringing this team together to do this extraordinary technical feat requires bringing people together who are, oh, here she goes. Here she goes. Bring people together. Amazing.
Thank you. What an amazing day.
How does it feel to have another rover on Mars?
It's amazing. To have Perseverance join Curiosity on Mars, and just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions, and then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us properties, size and properties of dust particles, because when we send people, we're going to have to deal with that dust. And this is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2, and that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith, and then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
And now that Perseverance has safely touched down on Mars, let's learn more about what's in store for the rover. Joining us now is Surface Mission Manager Jessica Samuels. Jessica, your surface operations team has now taken over. What are they doing now?
Yes. Hi, Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the entry, descent, and landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
Right. Exactly. One of the few interviews with that. Yeah, I mean, looking forward, it's just going to be an incredible few days. So even while we're celebrating and like high-fiving, fist bumping, whatever, here on Earth, Perseverance is still at work on Mars. All the orbiters are out of the field of view, so we're not actually talking to it right now. But what's happening is that what should be happening anyway is that the covers on these cameras are popping off. Another thing that's happening is there's sort of a switch of software because there was an entry, descent, and landing sort of mode that the rover was in. Now it is switching to surface mode in order that we're able to, start getting to work. So that's what's happening kind of over the next 4 or 5 hours. There's going to be another communications pass at about 4:30 Pacific, and then another one at 6:30 Pacific as we see the rover go through its transformation from interplanetary Voyager to geologist explorer.
So, we're just going to change software on another world. Yeah, that's what we do.
It's hard enough, right? When you're just like a laptop here on Earth, imagine doing it on another planet.
Every time I upgrade, it's like,
exactly
we're
where we
going to
are.
work tomorrow? Say it again, Derek.
I was just saying, where exactly are we? Bethany, do you have that info?
Where are we?
Well, okay, let me get my big globe. Oh, one moment.
We'll be here.
All right, I'm going to get the big globe. And this big globe is like super color psychedelic Mars because blue is low and red is high. So you've like got the big volcanoes of Olympus Mons, and then, the big canyon of Valles Marineris. And if we keep rotating, still rotating, I have actually put an orange spot near where we are. So Jezero Crater, so we're on the edge of this large impact basin called the Isidis Basin. And Jezero Crater is right about here. And so all those beautiful images you see of that delta in that former crater lake, that's a 45-kilometer crater. You can't really see it super well on my big globe, but that's where we are. And it looks like, I'm not 100% sure because they didn't really flash it on the scene, but it looks like we didn't land on the delta itself. It looks like we landed on the crater floor, so that I was kind of wondering if in the background of one of those HazCam images, there was a little bit of a scarp of a delta front. I think it looked like, from what I was seeing on the images in the background, they were kind of at the floor. And so we'll be able to look up toward the delta. I hope they put those images on the feed or post them on the web.
Did you just toss out a geology word, a scarf? A scarp?
Oh, a scarp. Yeah, that's kind of like a cliff face.
And so this is what geologists and it's what geologists and paleontologists go for. They want to see where Mother Nature has cut the scarp, so you can see. You don't have to do the digging or use your radar, Raquel.
That's exactly right. We can look underground with Raquel's radar. I just have to tell you, I have to share. I am just it's just kind of a moment because when I was in graduate school, my very first paper was about this location on Mars. So I pored over this particular spot for hours and hours. The first paper I published in graduate school was the finding of clay minerals in Jezero Crater. The second was about carbonates in Jezero Crater. And to think that image, that hours and hours in the lab poring over it, staring at it, we're now there. We're now actually there to be able to explore. So it's going to be amazing, y'all. This is a good spot.
It's a great spot right there.
In terms of like where we actually set down, if we didn't, set down on the delta, like you're saying, if we're like a little bit beside it, why would the craft have made that decision? Is that kind of like an autonomous decision that would be made, like based on, like, did it have programming to decide, okay, if I see something nice over here, I'm going to go there, or?
Yeah, basically. There was a pre-programmed hazard map on board. So you may have seen in the background this splotchy map of like reds and greens and blues. Those splotches were red is hazard, avoid it. Blues and greens are okay, aim for that. So if you heard them say terrain relative navigation, and one of the things that it was doing is during its controlled descent, it was trying to line itself up with one of those green-blue patches. So in terms of where exactly it landed within the ellipse, it kind of probably had to do how far down range it had gone before it got to the altitude where it needed to start looking for a safe spot. So I haven't seen, where it is in the bullseye of the ellipse. I look forward to, seeing that on the feed or on the web. But that's how it picked the spot. It was looking for one of those blue-green lily pads in its pre-programmed map.
So if you had your druthers as the landing person who picks the landing, do you want to be off to the side of the delta, or do you want to be right on the delta?
Both are great. We want to eventually visit all of the units. I'm super curious where we are. If I had my total complete druthers, I would want to have landed in the western part of the landing ellipse, because that means we can do the science of the crater floor, the science of the delta, and then get up out of the crater into even older units through the canyon that the river that fed into the crater carved. So we can go, up canyoning sooner.
You guys
I am happy we are safe on Mars.
And we can drive around. We got plutonium. And
right.
We got new wheels, new tires, better tires than Curiosity, which were fine tires, but they wore out a little, right? They got a little worn out.
Something I'm always asked is, like, how do we pick that place? I've been to a couple of the NASA of the landing site selection meetings, but people ask me that all the time. How do we end up deciding why Jezero of all places, and how does that process work? And I've seen you, Bethany, at all of the meetings, so maybe we can talk a little bit about that. That'd be cool.
Yeah, sure. I mean, so the landing site process started, oh gosh, how long ago? Maybe it was 2014 or something like that, with several dozen sites. So basically, you can only land on Mars where it's safe to land. You can only land below about -2 kilometers elevation. But then beyond that, it was left open to the science community. Propose a site. pitch it, right? So the first workshop was like the ultimate like pitch day, where there are 3 or 4 dozen landing sites and a quick rapid fire set of presentations. And by the end of the first 3-day workshop, that list had been narrowed down to about 12 or 15 that were then going to stay on the list and continue forward. And then they get vetted for safety. Want to make sure you can survive, so that chucks out some of them. But then you get down to there's 6 or 8 left, and they're all looking pretty good. They all have science pros and cons. Some of them are older, some of them are younger, some of them preserve lakes like Jezero, some of them preserve hydrothermal environments, some of them preserve volcanoes. So I have to admit, Jezero was I was co-proposer of Jezero. I was also co-proposer of a site called Northeast Syrtis and Midway. I slightly preferred that second site, but what's amazing about Jezero is that with Jezero, you can do Jezero science and then you can drive out and you can get the rest of the science too. So it's like the ultimate landing site, in my opinion, because you get the Paleo Lake and then you drive out and you get volcanic units, impact units, and ancient hydrothermal systems that are 4 billion years old. So with Jezero, you get a 3 billion year old lake and then a 1 billion years more back in Martian time.
How old is Mars? Is like Earth, 4.5 billion years, right? Maybe 4.6 if you're counting.
You got it.
Rocks coming together. But you threw out a geology word there, units, right? A unit is an area, a volume of geologic of rocks of the same kind, huh? Homogeneous rocks.
Yeah. You want me to take this, or Raquel take this too?
Yeah, no, it's a unit. It's usually it was formed at the same time, so there's some continuity, and so we can learn about the environment that formed each unit by studying that unit, because there was formed in very specific environments in a specific time. And that's when you see different layers, we call those different units, geologic units.
Yeah. It's just you throw these words around like Paleo Lake, geologic units, what you got there. Yeah, but it's a result of a lot of thinking. And you guys you try to imagine what 4 billion years is. I mean, a lot can go on in 4 billion years. If you try to count to 1,000, takes you 20 minutes. You try to count to 1,000,000, staying up all night, not sipping a milkshake, that takes you 11 plus days. If you want to count to 1 billion, not sleeping at all, 1 a second, it take you 31 years, 7 months. Okay. You want to count to 4 billion? You're getting into 130 years, 120 some years. Just counting every second. It's just really hard to imagine 1 billion years. And yet we can. We can imagine it. We can try to understand it. It's really amazing. The whole thing's amazing. So my understanding is they're off, the team is off looking for the next image. But man, landed on Mars. And Rob Manning pointed out, not only is it fuzzy, was the image a little grayed out or what have you, because there's dust on the lens cap, but there's still dust in the air after the rockets or whatever it sounds like on Mars. After that was done, then how long does it take you guys for dust to settle on Mars? Like, let's say on Earth, dust might take 10 minutes. If I blow up ash from the fireplace or off a book that's been on the shelf, it might take 10 minutes for dust to get to the floor or the bookshelf. How long does it take on Mars with the air so thin and the dust so fine?
This is a great physics problem for a high school class. Stokes settling.
Well, it involves aerodynamics. I mean,
depends on particle size and aerodynamics and the drag coefficient. And I have to admit, I cannot pull out those parameters for Mars off the top of my head.
Well, but having
Derek, you're a physicist, right? Aren't you a physicist? Can you pull that off the top of your head?
I don't have the calculation off the top of my head, but I would guess it's quicker. I know obviously on the moon it's much quicker, even though there's less gravity because you don't have that air resistance to worry about. So yeah, my suspicion would be it's a fair bit faster for dust to settle. But But I don't know. What do you think? If the particulates are really small, like maybe it is along.
Yeah, I mean it's a size function, right? So the big ones go first, then the little particulates, and then the finest of the fine.
Well,
I think it would
Doc,
be clearer too.
let me ask it of you all this way: how long was it before how long was it between rather the rockets blasting sand up or dust up, regolith up on Mars, and that picture coming down? That would give us a little delta, a time difference right there. It seems like, was it 10 minutes or a minute? So fun. It's so fun to think about this stuff because it means we're understanding. See, the premise of the bit, everybody, in science is that the universe is knowable, and the laws of physics we discover here on Earth must work the same on Mars. And if they don't, there's some other law of physics that we got to figure out. Over to you.
Yeah, I mean, that's truly the amazing part, right? And how can we land on Mars? Because we understand physics. Mars was where we expected it to be. So when we had a spacecraft there, we calculated the orbit, right? The drag of the atmosphere, the velocity through the atmosphere was what we expected it to be. We had a model that we could write out to predict it. The thrusters acted the way they acted, and so we have a new spacecraft on Mars. It's the power of the human mind, the power of scientific thought, and the power of engineering, right? Get it done. So I'm really excited about the future.
So, Derek, are you an engineer? Is your degree in engineering or a combined degree?
Engineering physics was my first degree, Bill. I don't know if you know about the engineer's ring. Can you see that?
Yeah,
it's a Canadian engineer.
Yeah.
Canadian engineer. Cool. Because I'm a mechanical engineer. I got a license. I got a number. Hey, wait a sec. Okay. I'm looking at the screen now that it's big. They've made me big. I mean, the screen big. So I just want to take a second. So here's a conventional globe of Mars. And here is, wait, I had it. Nobody leave this room. Yeah. Here's about where we landed on Mars. But, and then here is my fabulous MOVA globe, which you can do this with. And you guys, if you don't have a MOVA globe, I can't say enough good things. Sources of light make it spin. Light goes through the map, they call it, and then hits this little solar panel, and it reacts against the Earth's magnetic field. Big, stupid fun. It spins on your desk all day. Anyway, I hope many of you watching are members of the Planetary Society. That's why we're doing this. The world's largest independent space interest organization. And on the back of my business card, I have a picture of Mars, and there's the little instrument I worked on back in 2003. Anyway, check us out at planetary.org. And I mentioned this, I almost forgot, but the MOVA Globe Company is making you a deal. There it is. If you hook up now, you can get the Enceladus globe. Enceladus is a moon of Saturn that is also extraordinary, and we're sending a mission there in the coming decade. And one of our people on our advisory council, Deepak Srinivasan, is involved in this. Very cool. And if you call now, wait, there's more. You can buy any MOVA globe for 10% off. No, really, you guys. They are big fun. They're inspiring. They give you, they come in all different styles. So check it out. And of course, consider joining the Planetary Society. We go to U.S. Congress and other space agencies around the world to promote planetary science, because I like to say, although I applied to be an astronaut 4 times, you guys, I did. The planetary science is where we're making these amazing discoveries that just change the way we think about everything. And the exploration of Mars, as Carl Sagan said all the time, it's comparative planetology. It was a phrase he used often enough. You learn more about your own world when you study other worlds. And when you got globes on your desk, look at you guys, you've all got globes. Everybody's got globes back there. Yeah. You got a couple globes. Hey, Raquel, what is that behind you? The color-coded something or other?
So that's a geologic map of the moon's southern pole.
Well,
so the different colors.
I was just helping the other viewers understand it. I mean, so go on about that.
Yeah, so the different colors we were talking about, geologic units. So each color is a different geologic unit on the moon's southern pole.
And you guys are pretty sold on the idea there's ice there, right?
Yes,
100%.
that's right.
And Bethany, you got to go, right?
I'm like taking off the jacket that I, kept on to be the
wow.
formal president of Planetary Society, because now I'm just a member of the Mars 2020 team, just like the rest of them in the room. But I've actually got to go get to work and head to JPL. So I am so thrilled. It was a delight to share this with you, share this with everyone. If you like this, become a member of the Planetary Society, because we celebrate these moments together and we advocate for more of these moments so that they inspire the next generation. So thank you all. It's been a pleasure. Derek, Raquel, Bill, wonderful to share the moment with you.
It was just great, Bethany. You drive safely. And are you going to be living on Mars time?
We'll be living on Mars time for about 2-3 months. I'm going to be doing a hybrid myself. I got some day job things to take care of. But the team transitions to living like a Martian.
God, it's crazy. They get up 48 minutes later every day for 3 months. It's nutty. And my Jim Bell, who was on our board and was your predecessor as president, he just said he opened an account at Starbucks. It was just a lot of, but you drive safely, pal. Thank you for taking the time today to share this moment with us. And while I'm looking over my shoulder, now that you've made my camera big, there's that image right there is the picture of Earth taken by LightSail 2, which the Planetary Society, you all paid for. And we have extraordinary people in that mission team, and it's still flying. It's flying at kind of an extra year because we figured out how to maneuver a solar sail in Earth orbit. First time it's ever been done. Well, anyway, we're winding down. Derek, Raquel, thank you so much. Oh, there's a button. They're telling me there's a button on the homepage to become a member, of course, of the Planetary Society. It's you guys, we just have a cool website, very informative. We have the best journalists in the world for planetary science. We support this mission. The microphone goes back to Planetary Society, advocating it back in, after the Viking landing. I mean, I've been advocating for it in a small way since 1980, which is quite a while. That was when disco gave way to punk rock, a very important time, maybe. But also, just notice that Viking landed in 1976. The next mission wasn't till Sojourner in 1997. And a lot of that was the work of the Planetary Society, going to congressmen, senators, congresswomen, and advocating for planetary missions. And our day of action is coming up. It's going to be virtual this year. Instead of going to the U.S. Congress, we had people come from Alaska and Hawaii last year to go to the U.S. Congress, advocate with your representative, your senator. We're going to do it virtually this year, but I'm pretty confident we're going to be all back together next year. By the way, everybody, I got my second shot yesterday, and I guess I had no side effects. I mean, except I'm very excited about Mars. I'm not sure that was a side effect. Raquel, Derek, thanks so much, man. Woman, it's just cool. And best of luck in school. How much longer are you in for, Raquel?
I defend in hopefully in September. So I'm almost done.
You'll be
really
done?
Excited.
Your thesis will be done?
Yes, hopefully.
Wow, congratulations. Here's to you. That's amazing. That is huge. Well, you guys were winding down. Derek, Raquel, do you want to, can you add some big final?
Mars Donuts. We've got Mars Donuts, I think Raquel organized upstairs. So I'm going to go sort that out.
There we go. Some Mars
and you
Donuts.
pre-ordered them, huh? So
I did, because they were sold out.
They're red with chocolate sprinkles representing the roughness, the asperity, the units. The geologic units. Wow. Wow. That's, as the kids say, some pretty good grubbing right there. And you guys, speaking of grubbing, we do have experiments on this spacecraft to see if we can utilize resources in situ, in the situation. ISRU has been going on a long time. In situ resource utilization has been going back since the 1980s. This is one more step in understanding our place in the cosmos and what I like to call our place in space. All right, you guys. Thanks so much for taking the time. Thank you.
Thanks, Bill. It's been a pleasure.
It's that time of day here in the Pacific time zone. We got work to do on Mars. Thank you, everyone, for listening. Let's get out there, understand our place in space, and change the world for the better. Thank you.